Hello everyone. From this video tutorial, I'm going to discuss about binary multipliers. Actually, 2-bit multiplier. So let me explain what is a multiplier. So a multiplier is a combinational logic circuit that we use to multiply binary digits, right? Just like the adder and the subtractor, a multiplier is an arithmetic combinational logic circuit. It is also known as a binary multiplier or a digital multiplier. In normal um, binary multiplication, we multiply like this: 0 into 0, 0 into 1, 1 into 0, 1 into 1. This is AND gate. This represents the AND gate, right? So now in this case, what I want to do is in 2-bit multiplier using a half adder, right? I want to multiply this row with this row. So I want to multiply 0 0 with 0 1. If I want to multiply 0 1 with 1 1. So I need to use this some kind of a half adder and a multiplier to do this perform using logic gates. So here I have explained it further. So suppose you have two binary digits A1 A0, A1 A0, right? It should be this one and this one, or else this one and this one, right? Then B1 and B0, another one, this one and this one, right? Think I want to multiply this column by this column, sorry, this row by this row. Then the first row is indicated by this row, the second row is indicated by this row. So initially this BO is multiplied by AO, right? It is AO BO. Then we will writing here. Then this one will be multiplied by this one, A1 BO. Then finish. Then we will be moving downwards. We will leave a space here in normally binary multiplication. Here we multiply B1 A0. You can see B1 A0. Then B1 A1. B1 A1 is here. So then we will perform the addition. So if there's nothing to add here, then this one directly comes here. Here we have addition of two binaries, right? Here we have 2-digit number. Here also we have 2-digit number. So addition of 2-digit number can be performed using a half adder. So we have to use a half adder here in order to add these two. So if you add this one and this one, you will get this one. While adding, you will get a carrier to the next level. If you have two items to add, you will definitely have one carrier to the other level. So the carrier is marked as C. So A1 B1 is A1 B1 here, and that the following carrier is marked in here, right? So in the above calculation, A1 A0 is the multiplicand, A1 A0 is the multiplicand, B1 B0 is the multiplier, B1 B0 is the multiplier, right? The first product obtained from multiplying B0 with the multiplicand is called the partial product. So we obtain a product by multiplying by this. We will be multiplying this by this and this one. From this one and this one, we will be multiplying B0 with A0 and A1. So with that we will get a expression. That expression is called A1 B0. This is the partial expression, the partial product, right? Then the second product is obtained from multiply B1. This one will multiply with this one, and again this one will be multiplied by A1. So this is the another product, right? So the partial product 2, we name this one as partial product 1, then this one as partial product 2. So let me go to the logic gate. So now you can see here A1 and A0, right? A1 and B0 are multiplied. A1 B0, Here you can see A1 B0, A1 into B0, A1 into B0, this AND gate. Then I need A0 B0. You can see A0 come to this AND gate and this B0 come to this AND gate. Then A0 B0 output will be there. This is the A0 B0 output, right? Then after here we have this output of A1 B0, right? A1 B0 is added to the input of these two, A0 B1. Now in this gate we have A0 as an input, B1 as an input, this one. So to this will be get added, right? So the product which comes from here is added by this product. Actually A1 B0 product is come from this line, A0 B1 product come from this AND gate, and those two product will get added, right? And it will be get displayed here, and the remainder, the carrier will flow to the other level. Similarly A1 B1, A1 B1 is here as an input. With that input we have a previous carrier, and after adding that carrier we have output P3, and the remaining carrier will be displayed as P3, this one as P2 and the other one as P3. Hope you have understood. So this is using half adders. So if I extend this one, this is somewhat similar to this logic gate. Here you have a half adder, two half adders. So what is a half adder? Let me show you what is a half adder. Here you have a half adder, XOR gate and an AND gate. Half adder is XOR gate and an AND gate. So in my case, this XOR gate and this AND gate represent one adder, and this XOR gate and this AND gate represent another adder, half adder. Similarly like this is a one half adder, this is a one half adder. So this is a one half adder, this is a one half adder. There are four AND gates. So the items which are inside in this half adder has extracted and drawn as the logic gates in here, right? So let me simulate this one using an example in my Logism. So this is my Logism interface. So let me show you. You can see my example is I want to multiply 1 0 with 1 1. 1 0 means it's 2 actually. Decimal value is 2. This represent actually decimal value 2. This represent 1 1 represent the value 3. Right? So if I multiply 2 by 3, I should get the answer as 6. How can I write 6? Answer should be 6. You can see this is 2 to the power 0, 2 to the power 1, 2 to the power 2. 2 to the power 2 is 4, 2 to the power 1 is 2, 4 plus 2. Here we have the weighted value, this positional value, right? Here positional value is 4. It means 2 to the power 2. Here we have 2 here. Here we have 1. So here is a null value. Here we have 1. Here we have 1. So 4 plus 2 is 6. Right? So here I have represented 2. Here represented 3. I want to multiply 2 by 3. And I need to get this as the output. This 110 as the output. Also consider we have altogether 1, 2, 3, 4 digits. The output will be need to represent with 4 digits. So there's nothing problem if I add a 0 here for the output. So this is the scenario. So what I'm gonna do is I'm gonna start simulating this one using my Logism environment. So initially I need 2 AND gates. You can remember there were 2 AND gates, right? You can see here there are 2 AND gates. So I'm gonna place actually 4 AND gates, right? I'm gonna take 4 AND gates. Here we have AND. I'll be taking and I'll be reducing the number of inputs to 2, and I'll make this one heading towards south from here, and I'll just take copy paste of this one. And now I have 4 AND gates. Right, so initially we have an input like this and another input like this, which is it will go like this to up to here. I will show you from the my picture. So this one need to connect here, and this is another input, right? Because I need to get multiplied this 1 and 0, 1 and 1. So if I need to multiply 1 and 0, I need to multiply a1 by a0. Because of that, this is AND gate. I use this AND gate to multiply those two numbers, 1 and 0, right? This gate for to multiply this a1 and a0. So I will name this one as a0. I'll take an input. I'm heading towards south. I'll connect it here, and I need several inputs like that. I'll keep it just here. So I will name this one as a0. And this one also as a1, because I want to take the product of a1 a0, right? Because of that I took like this, right? And also I want to take the product of a1 b1, not a1 a0. I want to take the product of a1 b1, a0 b0. Sorry for the mistake. It's a1 b1. I want to take the product of a1 b1 because I want to multiply like this, 1 into 0, it's 0, 1 into 1, like that. Therefore I need AB combinations. So I need B0 A0, right? B0. I will name this one as B0. I name this one as B0. Right, now I have A1 B0 combination, A1 B0 combination, A1 B0 combination, A0 B0 combination, A0 B0 combination. Okay, now I have the first, right? First partial product is ready now. First partial product. What is my first partial product? This integer is getting multiplied by this one, and this one is named as the first partial product. So A0 B0, A0 B0 and A1 B0, A1 B0. So I have the product of 2A1, and the first partial product is correct, right? So I need the second partial product. I'm going to take the second partial product from these two AND gates. So I need the second partial product is A0 B1, right? A0 B1 and A1 B1 is the second partial product. So how I'm going to do is I'm just going to draw a upline here. I'll put a input here, and I need a B value. All the B values I marked as horizontally, okay? This length to this side, to this side. All the A values are marking to downwards, right? So here I have taken B0 value, right? I'm gonna mark B1 value here. Right. So this input as A0, same input here. So I'm gonna explain step by step how to draw this one. Now for this one, for the second partial state, for this, in order to arrange this level, in order to arrange this row, I have B1 A0. B1 comes here, A0 comes from here. That one is correct. Again I need B1 A1. Right? If I need B1, what I need to do is I need to connect either one of these to this input. Right? Let me check the circuit again. Yes, I need to connect it. I need to connect this one to here, and I need A1. Right, I will name this one as A1. Right. Now initially my first parcel and the second parcel is correct. This is the first parcel, first row, first parcel. This is the second parcel. The parcels are correct. So now what I need to do is I need to add these two parcels together. So I need to add these two parcels together using a half adder. The initial value, right? This 0 B0 A0 value, right? So it will be a direct output. It is not getting added to anyone. You can see if I multiply 1 into 0, it's 0 here. After that, this 0 will not be added to any of value in here. It is just directly printed as output. So I will printed this one as directly as the output. Then after this one, this is a input. This should be an input as a, I'll show you. You can see here, one of the input of half adder. This should be one of the input to half adder, right? I will take adder from here and I'll keep it here, and I'll reduce the number of bits to 1. Unfortunately, I cannot rotate this one, this adder, so I have to place it in here like as it is. So this is in this adder, I will name these inputs. So here we have the one input for a half adder. This is a one input, and this is another input. This one, right? This is the output of the half adder, this line, and this take the carrier one, the balance one, the forwarding value to the other half adder, or else the remaining part, not the remaining, the carrier value. If we add 1 plus 1, you will get 1 as the difference and 1 as the carrier, right? So here what we need to do is we need to connect this one, the incoming value, as the one of the inputs to this half adder, because we need to add the product from here. There's a product in this one, that product should be added, right? That product should be added to the product from coming, which product is coming from here. This is the second partial. First partial value should be added to the second partial. First partial value I have inserted into this one. Now I'm gonna second partial value, I'm gonna put to this adder, half adder, and then I'll be getting an output from here, right? While adding, there can be a carrier. That carrier should be passed as an input to the next level, next adder. So I need to take another adder, and I'll be placing it here. So this carrier should be given as an input to this adder, right? Then from this adder also you will get an output, right? For this adder, inputs are this carrier and the preceding digit, this digit, right? From this one also you can have a carrier which we can display. We will not go transfer. There will be a one carrier here also. So altogether we have completed our circuit right now. So this is some kind of a complex situation. If you refer the this thing, you can see it from here, right? So this is the scenario. This one directly passes to here. This one directly passes to here. We have 2 AND gates and 2 half adders. So if you rotate this another 90 degrees clockwise, this diagram will be nice. If you rotate this one 90 degrees, the diagram will be nice, and you can have output like this, output like this. So be familiar. So, and then I would like to add some pins in order to get output, so which is heading towards north. I'm gonna copy paste. I'm gonna fasten these ends. So my circuit is almost completed now. So let me show you the scenario. Right, let me start the simulation. Right, before that, let's check whether the design is correct or not. So here we have A1 as input. Okay, this one is also okay. A0, it's correct actually. Because of that, how I'm gonna assume this one is correct is as because all the colors, they match everything, so it gives an idea whether we have connected it as the actual way or else connected as a false way, so we can get a result. So initially, now I'm going to start simulation this one by using this example. Right, I want to multiply 1 0 by 1 1 1 0. My A1 A0 values are 1 and 0. For A1 A0, I'm going to substitute 1 and 0 1 and 0 1 and 0, correct. For A1 and A0, 1 and 0. For A1 and A0, 1 and 0. Right, okay. And for B1 and B0 both are high. Okay, B1 and B0 both are high. What I'm going to do is, I'm going to multiply 1 0 by 1 1 1 0 by 1 1. I get the output as 0 1 1 0 0 1 1 0. You can see it from here, 0 1 1 0. Right, so this proves our circuit is almost correct, and this is 2-bit multiplier using half adders. Only we are multiplying 2 bits, right? You can make this one as 3 or else 4. It's some kind of a complicated circuit. For now, this 2-bit, I have explained it here using this half adder. But if you want to make this one as 3-bit multiplier, what you need to do is, here we have the 3-bit multiplier. Initially we have 2 bits. Because of that, we had only 2 AND gates. If we are getting 3 bits, we have to add 3 AND gates. So input of those 3 AND gates and these 3 AND gates is fetched to half adders, and then those adders, those added half adders should be added to a full adder, because we will at the next stages we will be getting now increased number of input outputs, right? Because we will getting increased number of outputs while we multiply. Because here you can see we had 2 terms. After that, here we will have 2 terms, but there can be 3. Again, if there is there can be 4 terms. Like that, the terms will increase. While increasing the terms, in order to add those terms, we need a full adder. If there are 2 digits, we can add with a half adder. While adding this half and half add together, you will get a full adder, right? So this is the circuit of a 3-bit multiplier. So I hope you understood how to simulate this one uh, using Logism software. Also, if you need, I can perform another uh, uh, multiplication. So think, if I want to add if I want to multiply 0 1 multiplied by 0 1, the answer should be 1 into 1, it's 1. 1 into 0, it's 0 here. 0 into 1, again 0. 0 into 0, again 0. So the final answer should be 1. The final answer should be 1, 0, 0, and another 0, because if you add this one here, 1, 0, 0 added, it's 0. Here we put this 0 and another 0, because we have 4 integers here. So I'm going to add 0, 1, 0, 1. So let me simulate. 0, 1, 0, 1. Right, we got the answer as 3 zeros and a 1. 3 zeros and a 1. 3 zeros and 1. So this is working as a 2-bit multiplier using half-bit adders. So I hope you understood. Thank you everyone.